Hi everybody, Ms. Lee here. Today we're talking about derivatives of transcendental functions, specifically e to the x, a to the x, ln of x, and log base b of x. So the a there, that's going to mean any constant a, so any positive constant a. Generally we don't have a negative constant here. And then for this b here, same thing, any positive constant b. Okay, so I'm going to tell you what the derivatives of each of these are. And then we're going to do a couple of example problems. So first of all, the derivative ddx of e to the x. This one is the coolest one. The derivative of e to the x is e to the x. This is the only function whose derivative is itself. It's amazing. We'll talk more about it later. Then we have ddx of a to the x. And so this is similar to the e to the x, but there's an ln of a in front. So ln of a times a to the x is the derivative of a to the x. So it's basically multiplied by another constant because ln of a is a constant because a is a number. And if you take ln of a number, you're still going to get a number. All right. The derivative ddx of ln of x, that's going to be 1 over x. And lastly, the derivative ddx of log base b of x equals, and this is going to be similar to this one, it's going to be 1 over ln of b and then times x. Okay, so it's the same as 1 over x right here, 1 over x, but then it's got an extra constant there in the denominator. And it kind of lines up with this one if you look at it here. This is multiplied by an ln of a, this is multiplied by an ln of b. Okay, let's go ahead and do an example problem. So go ahead and find dy dx given y equals e to the x squared plus 1. Okay, so you can pause the video real fast if you want to go ahead and give this a try, but we'll go ahead and go over it. So what you'll recognize here is this looks kind of like the first derivative I gave you today, which is the e to the x, but we've got stuff in the exponent there. So we know that we have to use the chain rule because there's a function inside of the function. And so when we're taking the derivative of this, we take the derivative of both sides, dy dx equals, and the derivative of e to the something is just the e to the x, right? So the derivative of e to the x is e to the x. So we do e to the x squared plus 1. But since we treated like this was not there at all, that's the chain rule, right? That's an inside function. So you have to multiply by the derivative of the inside function. Well, what's the derivative of x squared plus 1? Well, that's just going to be 2x. Okay. Let's do one more example then. Also, find dy dx given that y equals 9 to the x squared all over ln of x cubed minus x. So first of all, I want you to identify the greatest operation that's going on here, and you'll see that that operation is division. So we have the division of two things, and so you know you have to use your low d high minus high d low all over low low. And so we know that this is low. And this is high. So we start with low, and let's just remember I highlight anything that's the original function, and then I underline with the same color anything that's the derivative. So we start with low, which is ln of x cubed minus x. That's low. D high, which is the derivative of 9 to the x squared. So I'm going to go ahead and use my formula. And over here, the formula says that if it's 9 to the x, so we're going to ignore that it's x squared for now. But if it's 9 to the x, it's going to be ln of 9 times 9 to the x. But since it was an x squared, you got to make that an x squared. So it'll be ln of 9 times 9 to the x squared. But I ignored that the x squared was a function. That's a function inside a function. So I need to multiply by the derivative of that x squared. So the derivative of that x squared is 2x. Okay, and so that's the d high. And we got minus high, which is 9 to the x squared. And then d low, the derivative of ln of x cubed minus x. So the derivative of ln of x, that's 1 over x. But in this situation, there's more stuff in there, so we have to kind of like cover that up and treat that as like it's an inside function. So it'll be 1 over x cubed minus x, and then times the derivative of that, because we want to multiply by the derivative of the inside function. That's using the chain rule. What is the derivative of x cubed minus x? Well, that's going to be 3x squared minus 1. So times 3x squared minus 1. And so we're underlining that because that's the derivative of the denominator. So that's low d high minus high and d low. And so then we have all over low, which is ln of x cubed minus x squared. And this is going to be dy dx. And if you're in my class, you don't have to simplify that. So there you have it. These are the derivatives of e to the x, a to the x, ln of x, and log base b of x. Happy day!